Prologue. The first night we looked up. The story of spaceflight begins before rockets, before equations, before metal. It begins with a human neck craning back and a sky so wide it felt like a question. For millennia we mapped that question with myths and calendars, with sextants and stories. Then, in the last heartbeats of the 19th and first of the 20th century, a few restless minds turned the question into mathematics and machines, and the distance between down here and up there began to shrink. Chapter 1. The Equation and the Spark. Long before any human rode a column of fire, the idea was made plausible on paper. In 1903, Konstantin Tsiolkovsky derived the rocket equation and argued that staged liquid propellant rockets could one day reach orbit. A generation later, Robert Goddard tested the first liquid fuel rocket in 1926, trading ridicule for results and proving controllable thrust was possible. These were not yet voyages, they were prototypes and patience. But the scaffolding of the future was set. Liquid fuel, staging, guidance, and the certainty that the problem was engineering, not magic. Chapter 2. Sputnik and the Shock of Orbit. On October 4th, 1957, a beeping sphere the size of a beach ball crossed the sky and altered the psychology of a planet. Sputnik 1 did not just orbit Earth. It orbited every conversation about power, science, and future. Its chirps said, "Space is not an abstraction. It is reachable." From that evening forward, the space age was not a phrase. It was a calendar. Chapter 3. First footsteps into vacuum history moved quickly. On April 12, 1961, Yuri Gagarin's 108-minute flight aboard Vostok 1 made him the first human in space. 2 years later, Valentina Tereshkova flew Vostok 6, becoming the first woman in space. These were brief voyages, but they expanded what human meant. The word cosmonaut, like astronaut, suddenly described us all. Chapter 4. Learning to work in orbit. After firsts came know-how. Crews practiced rendezvous and docking, lived days and then weeks in orbit, and walked in vacuum. Discovering spacewalking was as much choreography as courage. By the late 1960s, techniques for meeting, docking, and operating complex spacecraft were reliable enough to attempt something audacious. Take humans to lunar orbit and bring them home safely. Chapter 5. Around the Moon, the Christmas of Courage. In December 1968, Apollo 8 became the first crewed spacecraft to leave Earth orbit, loop the Moon, and return. The mission offered humankind a new self-portrait. Earthrise. Our world lifted over a gray horizon. It proved the Saturn V and the command module could do the job. A landing was now engineering, not faith. Chapter 6. Footprints on the Moon. On July 20th, 1969, Apollo 11's descent engine dusted the Sea of Tranquility, and 2 astronauts stepped onto another world. Over 6 landings, the Apollo program left experiments, tracks, and a new humility. The Moon was not a myth, it was geology, and we had boots in its dust. Chapter 7. Stations, shuttles, triumphs, and tragedies. The 1970s and 80s shifted focus from planting flags to learning how to stay. Skylab and then the shuttle era explored reusable vehicles and orbital construction. The shuttle enabled spacewalks, satellite deployment and repair, most famously the Hubble Space Telescope servicing missions, while also reminding us that spaceflight is unforgiving. Challenger in 1986 and Columbia in 2003 stamped permanent lessons about design margins, culture, and risk. Hubble, launched in 1990 and upgraded across 5 servicing missions, reshaped astronomy with images and spectra that redrew the universe. Chapter 8. The Long House in the Sky. Beginning in 1998, modules from multiple nations were launched, docked, and unfolded into the International Space Station, an engineering project the size of a football field that has hosted continuous human presence for over 2 decades. The ISS became a laboratory for life sciences, materials, fluid physics, Earth observation, and the art of living off Earth. Planning now looks beyond the station. NASA's transition plan anticipates retiring ISS near the end of this decade in favor of commercial low Earth orbit stations, with a controlled deorbit targeted for the early 2030s, enabled by a dedicated US deorbit vehicle. Chapter 9. The Renaissance of Reuse. Commercial partners transformed launch economics. In 2015, SpaceX achieved the first orbital-class booster landing and has since flown reusables routinely. In 2020, Crew Dragon returned crewed launches to US soil. Blue Origin and Virgin Galactic opened a suborbital chapter for research and tourism. Reuse didn't just cut costs, it changed cadence, more flights, more experiments, more shots on goal. Chapter 10. New Eyes, Webb and the Early Universe. Launched late 2021, the James Webb Space Telescope delivered its first images in July 2022. Pillars of starbirth, deep fields studded with ancient galaxies. Webb also made the first unambiguous detection of carbon dioxide in an exoplanet atmosphere, WASP-39b, a milestone for studying worlds beyond our solar system. Its data continue to push the cosmic frontier back toward the first few 100 million years after the Big Bang, challenging and refining models of how quickly galaxies and black holes assemble. Chapter 11. Robotic Pathfinders and Planetary-Defense. On Mars, Perseverance has been drilling, caching rock cores, and scouting ancient river deltas, while its tiny partner helicopter, Ingenuity, proved powered flight on another world across 72 sorties before its retirement in January 2024. Closer to home, humanity tested a planetary defense idea. In 2022, NASA's DART spacecraft struck the asteroid moonlet Dimorphos and measurably shortened its orbit. ESA's Hera spacecraft, launched in 2024, is en route for a forensic follow-up in 2026. And OSIRIS-REx returned the first US asteroid sample in 2023 and is now retasked as OSIRIS-APEX to study Apophis during its close Earth pass in 2029. Chapter 12. Back to the Moon, Together. The Artemis program aims to return humans to the Moon and establish a sustainable presence near the South Pole, using Orion, the SLS rocket, the Gateway outpost, and commercial landers. NASA's schedule has shifted. Artemis 2, the first crewed Orion flight around the Moon, is now targeted no earlier than early 2026, while international partners contribute modules, logistics, and science. In parallel, China operates the Tiangong space station and maintains a publicly stated goal of landing astronauts on the Moon by 2030. However the flags shake out, the direction is the same. Back to the Moon as a means to learn how to go further. Chapter 13. Why we go spaceflight, has always braided 3 strands: curiosity, capability, and consequence. Curiosity asks what's out there and what we can become. Capability answers with new tools, reusable rockets, deep space habitats, life support that can run for months without a resupply launch. Consequence forces us to use all that wisely. Accidents teach, budgets constrain, politics change. Yet the line of progress, zigzagging, yes, keeps climbing. If we can learn to live off-world without breaking ourselves, the skills forged on a dusty rim of crater ice or in an orbital lab will echo back home. Cleaner power, closed-loop water, sturdier systems, bolder education. Epilogue: The next horizon. Someday, a child will study these decades the way we study the age of sail, as the time we learned the roots and winds of a new ocean. The first travellers will be remembered not just for where they went, but for how they turned exploration into residence, and residence into stewardship. From there, Mars is not a fantasy, it is a timetable. From Mars, further still, the sky remained a question. We just learned how to answer it. One cautious step, one careful burn, one brave orbit at a time.